Hi guys, in this video I cover constructors. I talk about the default constructor and parameterized constructors. On the left I have a class that represents a dog. It has three member variables for the name, for the breed, and for the age. Each of these member variables has a pair of getters and setters for the name, for the breed, and for the age. And finally I have the toString method that returns a string representation of an object, simply by concatenating the name of the member variable followed by the value stored currently in the member variable, and this for name, for breed, and for age. On the right I have a class program. This implements the main method. Now let's create an instance of the dog. I call this simply dog and call new dog. So new dog here invokes the constructor. The constructor always has the class name followed by parentheses. It's a special function that is used to initialize member variables of a class or do any other required initialization of an object. For example, if we have a class that represents a network connection or connection to a database, the constructor could establish the connection. Now, in this class here, I did not explicitly implement a constructor. And when you don't implement a constructor, it will automatically generate the default constructor for you. So that is why I can call the constructor here, even though we don't see it in the code. I could make this explicit, so I use the public keyword so that the constructor is accessible from anywhere, and then the constructor, any constructor does not have a return type, and the name of a constructor has to match the class name. So my class is dog, so this has to be dog. This is now the constructor. So let's output here the dog. So I use system print outline pass in dog, and when I run this, currently I get name is null, breed is null, and age is 0. That is because I did not initialize these member variables, and so it takes the default value for each type. String and breed are objects, so they are part of the string class, and because I did not initialize it to a new object, they reference both null. This is for all object types. Now, for the class, for the age, this is an integer, and the default value for an integer is 0. Let's say I want to change this. I could write in the constructor that the name by default should always be Woofy, and the breed by default should always be a beagle. And let's say the age I set to 1. Now when I run my code again, you will see that this now is Woofy, Beagle, and 1. That is because this one called the constructor here. It ran these statements, initialized name, breed, and age to these values. And so any object that I create will initialize these values accordingly. Now this could be done in another way. I could also directly initialize each member variable up here, so I wouldn't have to write it in a constructor. Now, a class can have more than one constructors, and it doesn't even need to have a default constructor. So for example, if I say I don't want to initialize them here, but I require that every time an object of my class is created, I require some arguments. I define a constructor with the parameter name, for example. That means every time a dog is created, a name has to be provided. And so I use here this.name. This refers to the new object. So the new object .name, it's the member variable, and I assign the argument that is passed to it to the member variable. Now I get a compile error over here because the default constructor no longer exists. So this shows you If you do not have any constructor, it will automatically generate the default constructor for you. But if you create any constructor at all, be it the default one or non-default one with a parameterized constructor, like in this case, it will not generate the default constructor for you. So right now, the only constructor that exists is this one, and that requires a name argument, which I do not pass in over here. That is why I get why this no longer works. So I can do two things. I could say I pass in an argument here, and then my code works fine. I can run this. Woofy is now passed to the constructor, so it's assigned to the parameter here. And this value, Woofy, is then assigned to the member variable name. And when I output it, I see it here as part of the object. The other way, let's say I still want to allow to just run a code without passing any arguments in. What I could do is I overload the constructor, just like overloading a function. So I define a second constructor, also matching the class name, and I just leave this empty. Or I could write some code, obviously, but now I have two constructors. So now anybody who wants to create an object of this class has the option to use the default constructor without any arguments, or they could use the parameterized constructor and providing a name. And so I can extend this to additional constructors, just whatever I need for my class or what I want to allow. Let's say I want to allow another one, string name and string breed. And here I initialize the new object, this.name equals name, and this.breed equals breed. Now let's create some more objects over here. Let's say I have a dog, new dog, Woofy. This one will I call dog2, or let's actually call it Woofy, and I output this. So this one I called the constructor with a single argument, and then I could also call a constructor. It's called wow, and this is a Chihuahua, and I output this one as well. Now when I run this, we can see the first one I didn't provide anything, so this one is still has the default values. Second one I provided just the name, so the name is assigned to the member variable, so it has Woofy. The other ones have default values, and the last one I pass in the name and the breed. Now this can be useful, especially if you don't have the option of a parameterized constructor. You would have to always call the setter, right? For this dog, we have to call set name and dog set breed. So we have 3 statements to initialize it, versus here it's just a single statement. So this is easy to read and much quicker. It's a single statement to accomplish the same thing. So it's good to have a parameterized constructor. Now, the other reason why constructors are useful is if we want to may have constants that we only want to allow to be set during construction of an object, and they should not be changed later on. For example, let's say the name, or let's say the breed cannot change. So the breed is final. What I see here is this one, I have to initialize it. So I can say if nothing is provided, I leave it an empty string. And then here, if nothing is provided, I again say breed is empty. Oh, this should be breed here. And here I initialize it. Now I also would have to remove the setter because it can no longer be set. It cannot be changed. So I remove setter method. And now when I pass in the breed here, so breed, this no longer works. So when I pass in the breed, I can set it when I create a new object, but once I have a dog of a certain breed, the breed cannot be changed. It's really, that is the breed for the lifetime of the object and for the lifetime of the dog. So that is another reason why we use constructors. With the setter, I could set it once, but I could set it multiple times. I don't have the option to do this. Now there's one last thing. Sometimes constructors, when we have multiple constructors especially, we don't want to rewrite the entire code. Let's say I have a constructor here that has name, breed, and now also age. Now you can see I initialized name and breed here, name, breed here, name, breed here, name here. So it's duplicated code that I have to write over and over. I have the option in Java also to call another constructor from a constructor. So I could call from this constructor, call this constructor up here. This I could do with the this keyword. So this, and then I pass a name and breed. And so now I have the this keyword here. I call, and it calls the other constructor, so I don't have to rewrite the entire code. I hope you enjoyed this video. Thank you for watching.